Now we will see another concept, conversion of NFA to DFA. Okay, so here conversion of NFA to DFA, it's very important. Actually both is possible. DFA to NFA is also possible and NFA to DFA is also possible. So here first we will see conversion of NFA to DFA. The question is, by seeing this automata only you can confirm that this is a NFA. Why? Because with the same input symbol it is going to the more than one state. Q0 on 0 it is going to the Q0 and Q0 on 0 it is going to the Q1. So this is possible in NFA only. So by seeing the diagram you can come to know that this is a NFA. So to convert NFA into DFA, first you need to follow some steps. First you need to find out the possible states. So here possible states are, here how many states you will be having here in a NFA? Two states you are having. So to convert NFA into DFA, the possible states will be 2 power 2. Okay, which is nothing but here the number of states in a non-deterministic finite automata will be 2. So in a deterministic finite automata the number of states will be 2 power qn. Qn is nothing but here 2. So here 2 power 2. So 4 possible states will be occurs in a deterministic finite automata. So from this NFA you are going to be finding possible states for the deterministic finite automata. That is nothing but a 4. If 3 states are there in a NFA, you will get 2 power 3. Okay, if 2 states means 2 power 2, which is nothing but a 4. So how many? 4. That 4 possible states are pi, Q0. Okay, Q0. Pi also you need to consider. Okay, empty Q0. Only Q1 you can mention and possible of Q0, Q1. These are the states you can mention. So here we are going to be states now. You need to write in the square braces. Okay. So after finding the possible states, you need to find out the set of input symbols. So set of input symbols for the deterministic finite automata are same as a NFA. In a NFA, what are the set of input symbols you will be having? 0, 1. Same input symbols you need to mention. And transition function we will see later. Next, initial state. Initial state you need to find out for the deterministic finite automata. Whatever the initial state you will be having for NFA, same will be for the deterministic. Same will be for the deterministic. So here Q0 D is nothing but a Q0 only. And final state you are going to be finding. Final state is nothing but a set of all set of all states of non-deterministic finite automata of final state. This meaning is nothing but a, here what is the final state in the non-deterministic finite automata? Q0. So possible wherever Q0 appears in the total states, that all you need to write. So what are the final states? Q0, comma, Q0, Q1. Okay. Next, after finding the final state, again we will see final state. How to find the final state for the deterministic finite automata means, first you need to check the final state for the NFA. So here final state for the NFA is Q0. So wherever the Q0 appears in all the states, that all will become the final states for the deterministic finite automata. So here Q0, Q0, Q1. Q1 doesn't come. Why? Because in the Q1 only Q1 is there. There is no Q0 combination. So it doesn't come. Okay. So next, finally, you need to take the transition function. Okay, this is important. So always start from the initial state only. So start from the initial state and you need to mention the set of input symbols. So here first initial state Q naught on 0. Q naught on 0, where it is going? Q naught on 0, it is going to the state Q naught and as well as Q1 also. Okay. So transition function of Q naught on 0, it is going to the state Q naught as well as, okay, union Q1 also. Okay, Q naught comma Q1, which is nothing but you can write it as a Q naught on 0, it is going to the state Q naught, Q1 also it is going. Okay, next Q naught on 1. Q naught on 1, where it is going? It is going to the state only one state Q1. So after applying the inputs on the state, if there is a new state appears, for this new state also you need to apply the set of input symbols. Until the new state appears, you need to do this process. If new state doesn't appear, stop the procedure. So for me here, Q naught Q1 is the new state only. So Q naught Q1 completely one state. On this state, you need to apply the set of input symbol 0. This meaning is nothing but a Q naught on 0 union Q1 on 0. We will see. Q naught on 0. Q naught on 0 means where it is going? Q naught and as well as Q1. So Q naught Q1 on 0. Okay, transition function of Q naught Q1 on 0. This meaning is nothing but a Q naught on 0. Q naught on 0, it is going to the Q naught Q1. Again Q1 on 0 also you need to apply. Okay, it's better to apply the union. So Q1 on 0. Q1 on 0, where it is going? It is going to the Q1. So here Q1 also you can mention. So union means Q naught Q1. So Q naught Q1 on 0, it is going to the state Q naught Q1. Again Q naught Q1 on 1 means Q naught on 1 union Q1 on 1. If you do that, you will get same Q1 Q naught or Q naught Q1, both will be same. You will get Q naught Q1. Now this one is over. Now you check. This Q1 is the new state. For this new state, I did not apply the set of input symbols. So Q1 I am considering on the left hand side, and again you need to apply the set of input symbols. Q1 on 0. Q1 on 0. Where it is going? It is going to the state Q1. Q1 on 1. Q1 on 1. Where it is going? Q1 on 1. It is going to the state Q1 and as well as Q naught also. So Q1 on 1. It is going to the state Q1 and Q naught. Q1 on 1. Q1 on 1. It is going to the state Q1 and Q1 on 1. It is going to the state Q naught. So this one is over. Again if you observe here, Q naught Q1 already I applied, no need to do. Q1 Q naught already I applied, no need to do. Q1 already old state, no need to do. Q1 Q naught already old state, no need to do. So this process is completed. If there is no new state appears means stop the procedure. Now this becomes a DFA. Now you need to design a DFA for this transition diagram. So how many states you need to consider? Q naught Q1. Always remember that Q naught Q1 will be the new state. This two you need to consider as a one state. Okay, you should remember this. Okay, Q naught Q1 will become the new state. Don't consider Q naught as another state and Q1 as another state. Both combination you need to consider. Next, Q1 is the new state. Always consider that Q naught is the initial state. And already we discussed that wherever the Q naught appears, that all will become the final state. So Q naught is appearing here. So this is the final state and subset of Q naught also considered as a final state. So here Q naught you need to consider as a final state, and subset of Q naught also consider as a final state. Next you need to draw the diagram. So Q naught on 0, where it is going? Q naught on 0 it is going to the state Q naught Q1. Q naught on 1, where it is going? Q1 state. Q naught Q1 on 0 it is going to the state Q naught Q1. On 1 it is going to the Q naught Q1. Q1 on 0 it is going to the Q naught. Q1 on 1, where it is going? It is going to the state Q1. This is nothing but a designing of a DFA. This total part is nothing but a DFA. So this is nothing but a NFA. For this NFA, we designed the DFA. This is important.